Hey everyone, and welcome back to the channel. Today we're diving deep, literally, into one of Europe's most vibrant cities, Naples. Now, you might know Naples for its incredible pizza, its rich history, or maybe the looming presence of Mount Vesuvius. But what if I told you there's something even hotter brewing right beneath the city streets? Something that scientists are calling a fiery secret. We're talking about Campi Flegrei, which translates to the burning fields. It's not your typical volcano with a pointy cone. Imagine a massive, sprawling, underground volcanic system, a supervolcano right next to a city of 3 million people. For decades, scientists have been studying this area, trying to understand its weird behavior. The ground literally breathes. It rises and falls, a phenomenon called bradyseism. Sometimes it rises by several feet over a few years, forcing entire towns to relocate, and then it slowly sinks back down. So, what's causing this? The classic theory was that a giant single magma chamber, like a huge underground lake of molten rock, was filling up and emptying, pushing the ground up and down. Think of it like inflating and deflating a giant rocky balloon. This model made sense for a long time, but recently, new research has thrown a massive curveball into the mix. A team of researchers decided to look closer, using advanced seismic imaging techniques. It's kind of like giving the Earth an ultrasound. They sent sound waves deep into the crust and listened to how they bounced back. Different materials like solid rock versus molten magma change the way these waves travel. And what they found was fascinating. Instead of one huge magma chamber, they discovered something completely different. The old theory of a single giant magma balloon under Campi Flegrei is being challenged. The new evidence points to a much more complex system. Picture this. Deep beneath the surface, around 8 kilometers down, there's a massive source of heat and magma, what scientists call a hot zone. This is the engine room of the whole operation. But the magma doesn't just sit there. It forces superhot fluids, gases, and smaller pockets of molten rock upwards into the shallower crust, just 3 to 4 kilometers below Naples. So instead of one big chamber, it's more like a network of smaller, sizzling hotspots and channels filled with a mix of rock, melt, and volcanic gases. It's this shallower system, this geothermal plumbing, that's directly responsible for the ground rising and falling. When this network gets a fresh injection of hot fluids from below, the pressure builds, and the ground swells. What's even crazier is that they found a specific layer of rock, about 3 kilometers down, that's acting like a temporary lid or a cap. This rock is less permeable, meaning it traps the hot fluids and gases rising from the deep hot zone. This trapped pressure is what pushes the ground up. The recent study suggests that the rock layer right above this cap has been stretched and weakened over time by all this pushing. It's becoming more fractured, more brittle. Think of it like putting a lid on a pot of boiling water. As the steam builds up, the lid starts to rattle. If the lid gets weaker, it becomes easier for the steam to escape. In the case of Campi Flegrei, this means the ground is becoming more sensitive to even small changes in pressure from below. A weaker crust could mean that it takes less pressure to cause an eruption. This discovery is a game changer for how we monitor volcanoes. Instead of just looking for a big magma chamber filling up, scientists now need to pay close attention to the state of this shallower rock. They're monitoring the strength of the crust itself. Is it getting weaker? Is it more prone to fracturing? These are the critical questions. The researchers used a clever method to figure this out. By analyzing how seismic waves slow down when they pass through fractured rock, they could map out the weakness of the crust. Their findings showed that the area that experienced the most uplift in recent decades is also the area where the crust is the weakest. It's a direct link. The pressure from below has been stressing the rock, making it more fragile. So, what does this all mean for the people of Naples? Does it mean a massive eruption is imminent? Well, not necessarily, but it does mean the situation is more complex and potentially more volatile than we previously thought. The volcano isn't just reawakening, its structure is physically changing. The cap rock is losing its strength. This makes predicting what will happen next incredibly tricky. The system could just vent its pressure through smaller earthquakes and gas releases, as it has been doing. Or the weakening crust could make it easier for magma to find a path to the surface. The tipping point between a non-eruptive crisis and an actual eruption is becoming finer. This new understanding highlights just how dynamic our planet is. The ground beneath our feet isn't static, it's a living, breathing system, especially in a place like Naples. Scientists are now armed with this new knowledge, allowing them to refine their monitoring and, hopefully, provide better and earlier warnings if things start to get dangerous. It's a powerful reminder that there are still so many fiery secrets hidden beneath the surface, and we're just beginning to unearth them. It's a testament to scientific curiosity, constantly questioning old ideas and using new technology to get a clearer picture of the forces that shape our world. The story of Campi Flegrei is far from over. In fact, it feels like we've just started a thrilling new chapter. Thanks so much for hanging out and exploring this incredible geological detective story with me today. If you found this as fascinating as I did, make sure to hit that like button, and don't forget to subscribe and turn on notifications so you don't miss our next deep dive. Let me know in the comments what you think about this discovery. Stay curious, and I'll see you in the next video.